Let's consider the resistances in a couple of simple circuits. First, a series circuit with two resistors. These may be lamps or any electrical device. We label their resistances R sub 1 and R sub 2. It's often desirable to know what single resistor could replace the two resistors and result in the same current and same energy drawn from the battery or other voltage source. This is the equivalent circuit resistance. For a series circuit, R sub equivalent is simple enough. It's the sum of the individual resistors, because the same current has to pass through each of them in turn. Resistances add. Suppose R sub 1 were 4 ohms and R sub 2 6 ohms. These easy numbers make the concept clearer. Then the equivalent resistance is 4 ohms plus 6 ohms equals 10 ohms. The amount of current in the circuit would be the same as if the two resistors were replaced with a single resistor of 10 ohms. Hey, the battery wouldn't know the difference. If there were additional resistors in series, then the equivalent resistance would extend for n number of resistors in series. Now consider this parallel circuit. We know that current takes separate pathways in a parallel circuit. Current through one branch doesn't encounter the resistance of any other branch. The total circuit current is equal to the sum of the currents in each branch. That is, I sub total equals I sub 1 plus I sub 2. And from Ohm's law, substituting V over R for each of the currents I, the single equivalent resistor that can replace the two resistors can be calculated from this equation. And since the battery voltage is the same as voltage across each of the branches, we can divide the equation by V and get yum. So the reciprocal of the equivalent resistance equals the sum of the reciprocals of the two single resistors. With a bit of algebra, we can convert this equation to the product of the resistors divided by their sum. This is the product over sum rule for a pair of resistors in a parallel circuit. Suppose as before, R sub 1 is 4 ohms and R sub 2 is 6 ohms. The rule tells us that R sub equivalent is equal to 4 times 6 divided by 4 plus 6 equals 2.4 ohms. So the equivalent resistance of the two-branch circuit is 2.4 ohms. Notice this is a lot less than the 10 ohms for the same two resistors in series. In the special case of a pair of identical resistors, the equivalent resistance is half the value of either resistor. Half when both of the resistances are the same. In summary, the product over sum rule applies only to a pair of resistors in parallel. More generally, the equivalent resistance of a parallel circuit with n number of resistors can be found from this extended equation. Here's what's fascinating about parallel circuits. The equivalent resistance of any parallel circuit is less than the resistance in any of its branches. Less. This is similar to increased checkout lanes in a supermarket. More lanes means less resistance to the flow of traffic. So it is with more branches in a parallel circuit. More branches reduce circuit resistance and allow greater flow. Got it? I hope so. I want to leave you with a question. How many 4 ohm resistors must be connected in parallel to create an equivalent resistance of 1 ohm? Until next time, good energy.